Hypothesis 2. He's just come from the tropics. Then he sees the stiff arm, the tired face, the final, best explanation that ties it all together: an English army doctor just back from a rough time in Afghanistan. None of these are 100% certain, but when you chain them all together, you get a stunningly accurate conclusion. So the key takeaway is this: Holmes wasn't a master of deduction, he was a master of abduction.
So, how does all of this detective work connect back to the world of AI? Well, you can kind of think of the two major schools of thought in AI as two different types of detectives. They're each trying to solve problems, just in their own way. Let's meet our suspects. First up, we've got suspect number 1, symbolic AI. You can think of this as the deductive detective. This is your classic old-school AI. It works with a big rulebook of facts and strict formal logic. It's powerful, it's precise, and it operates with the kind of certainty you only get from pure deduction. Our second suspect is connectionist AI, which is more like an inductive detective. Now, this one is totally different. Instead of starting with rules, it creates them by finding patterns in massive amounts of data. After looking at a million pictures of cats, it concludes that this next furry thing with pointy ears is probably also a cat. It's all about pattern matching, not creative explanation. The big problem with our first suspect, the deductive detective, is something called the closed world assumption. Basically, it assumes that its knowledge of the world is complete. It's a genius detective for sure, but only if the crime happens in a locked room where it already knows everything and everyone inside. But of course, the real world is messy. It's open, it's unpredictable, it's basically infinite. You can never program in all the possible facts and rules. That closed world assumption, just like Sherlock's perfect algorithm, completely falls apart the second you run into something new.